Hi, my name is Bill Reddington, and today I'm going to talk about partial differentiation. Now, sometimes the variation of one quantity depends on changes taking place in more than one variable. For example, imagine we have a cone of radius r and height h. Now, the volume of the cone is given by 1/3 pi r squared h. So, if either r or h changes, the volume will change. So we can say that the volume is a function of r and h. Now, to differentiate functions like this with two variables, first we keep one of the variables constant, and then we differentiate the second variable with respect to that variable. And the result is what we call a partial derivative. Now, when differentiating functions with more than one variable, we use the following symbol, which is called the curly D symbol. Now, going back to the volume of the cone we had earlier, the following, dv dr, means the partial derivative of v with respect to r with h kept constant. So if we bring the h to the front, we could write dv dr is 1/3 pi h times the derivative of r squared. So differentiating r squared, we get 2r, and bringing the 2 to the front here, we get 2/3 pi rh. So therefore the partial derivative of the volume with respect to the radius is 2/3 pi rh. So now let's consider dv dh, which is the partial derivative of the volume with respect to h with r kept constant. So if we differentiate the volume, keeping r constant, we get 1/3 pi r squared times the derivative of h. And differentiating h, we just get 1. So dv dh, the partial derivative of the volume with respect to the height, is 1/3 pi r squared. So now let's have a look at an example. Here we're given a function z, which is dependent on two variables x and y, and we're asked to find the partial derivative of z with respect to x and the partial derivative of z with respect to y. Now, if you like, we could rewrite this function as x cubed plus y cubed times 1 minus 2x squared y. And to get the partial derivative of z with respect to x, first we keep y constant, and then we differentiate the function with respect to x. So, differentiating x cubed, we get 3x squared. Differentiating 1, or any constant, we get 0. And differentiating x squared, we get 2x. So 2x by minus 2y is minus 4yx. So the partial derivative of z with respect to x is 3x squared minus 4 times yx. Now, to find the partial derivative of z with respect to y, this time we keep x constant and differentiate with respect to y. So this becomes x cubed, which is a constant, times the derivative of 1 plus the derivative of y cubed minus 2x squared times the derivative of y. So again, differentiating 1, or a constant, we get 0. Differentiating y cubed, we get 3y squared. And differentiating y, we get 1. So we're left with the partial derivative of z with respect to y is 3y squared minus 2x squared. So now pause the video and see, can you have a go at this question. So once again, you're given a function z made up of two variables x and y, and you're asked to find the partial derivative of z with respect to x and the partial derivative of z with respect to y.